Hello everyone. In this short tutorial, I'm going to talk about the block diagrams and how one can use them to interpret the rocks in 3D. First of all, why do we need block diagrams? Block diagrams are tools for representing rocks in 3 dimensions and are useful if someone is trying to understand the subsurface rocks and structures in any region on Earth. Here is an example of a block diagram which allows us to see the surface of the earth or the map view and the two sides or the cross-sectional view. In the problems regarding the block diagrams, we are mainly given the map view along with the strike tip information of the beds. Based on this information, we are required to draw how the two sides of the block would look like. Here is an example of such a problem and we'll solve it using PowerPoint slide. We have a block diagram here on the right whose map view or face 1 is shown on the left. As seen from the symbols, the strike of the bed is perpendicular to the north and the beds are dipping south. Based on this information, we try to think how beds would appear on face 2 and face 3. Let us first consider the face 2. Since we know that the beds are dipping towards the south direction, we can draw the dipping beds on this face. I will use the drawing tool for this purpose. The beds would look something like this, shown in this figure. Now the question is, how do I know what the vertical depth is at which these beds intersect the face 3? That means this vertical distance that I'm showing through the pointer. Note that we already know the dip of the beds. Since face 2 is perpendicular to the strike, the angle over here is actually the true dip angle, which is equal to 45 degrees. A key point to remember here for the block diagram is that we never measure this angle using a protractor. Instead, we would use the ratios of the line segments and trigonometric formula to determine this length. For example, here in triangle ABC, the triangle is a right triangle. 45 degree is the dip angle that we have already been given. We can measure the line length of AB, and through trigonometric identity we can write tan 45 equals BC over AB. Since tan 45 is 1, BC is equals to AB. That means the length of this BC or the vertical depth is simply equals to the measure of this line AB. How do we measure this line? We can use a scale like this, and we can simply measure line AB, which is shown here as 3 centimeters. We can mark this point 3 centimeters below here using this marker. Now again, using the drawing tool, we can simply draw this line. Similarly, if we want to draw the other bed, we can simply measure another distance, the horizontal distance, which if we see here, always make sure that the scale is parallel to the edge of the block. So if we see, this is 1, 2, 3, 4, 4.8. So all we need to do is measure 4.8 from here. open, it will come here. Similarly, we can join this. So this gives the most accurate representation of the beds on phase 2. Now, I would give you a few seconds to think how beds would appear on phase 3. If you have thought that the beds would appear horizontal, that is correct. This is because the phase 3 is along the strike of the beds. We can simply draw a line, horizontal line such as this. A horizontal line will be parallel to the edges of the block as shown here, and this completes the three-dimensional view of this sandstone. To shade this sandstone, what we can do is we can use the freeform drawing toolbox, which allows us to first trace this body of sandstone, and then we can simply use a pattern to fill it. In this way, we have plotted the three-dimensional view of a sandstone body. Similarly, we can carry the same procedure for each beds and try to figure out how all different beds would look like in 3 dimensions. This diagram here shows a completed block diagram. Note that on phase 2, the boundary of the shale is dotted. Since based on the map view, we do not have enough information to comment on this unshaded portion. In this way, we can have a complete block diagram that can represent rocks in 3D. Thank you.